A car starts moving rectilinearly, first with acceleration w equals 5.0 meter per second square. The initial velocity is equal to 0. Then uniformly and finally decelerating at the same rate w comes to stop. The total time of motion equals tau equals 25 seconds. The average velocity during the time is equal to v average equals 72 km per hour. How long does the car moves uniformly? In this question, the duration of travel is tau equals 25 seconds, v average equals 72 km per hour. So we can obtain the total displacement s as v average tau divided by 3.6 meter. Let the car move t1 second while acceleration and t2 second while uniform motion with velocity v and t3 second while deceleration. As shown in this figure, this is the time duration for the acceleration, this is the time duration for uniform motion, and this is the time duration while deceleration period. So while the acceleration duration, we can write the equation v equals 0 plus wt1, which equals wt1. Let's call this as equation 1. And while the deceleration time duration, the final velocity is 0 and initial velocity is v and the acceleration is minus w. So we can write the equation 0 equals v minus wt3 or v equals wt3. Let's call this as equation 2. Comparing the equation 1 and 2, we get t1 equals t3. The total time of motion is t1 plus t2 plus t3 equals tau. If we put the value of t3 as t1, we will get the value of t2 as tau minus 2 t1. Let's call this as equation 3. From the consideration of time duration t1, t2 and t3, in which the car has the acceleration, deceleration of constant value and uniform motion, we can get the equation of displacement as s equals half wt1 square plus wt1 t2 plus wt3 square minus half wt3 square, using the kinematic equation that displacement equals ut plus half at square. So on simplification, we get the displacement as s equals wt1 square plus wt1 t2. The value of t2 as given in equation 3, t2 equals tau minus t1, can be put to this equation and we get the right hand side as t1 square plus t1 multiplied by tau minus 2 t1. The left hand side is the displacement, which can be put from the value of displacement obtained from here. So we get the equation v average tau divided by 3.6 w equals t1 square plus t1 multiplied by tau minus 2 t1. On simplification, we get t1 square minus tau t1 plus v average tau divided by 3.6 w equals 0. This is a quadratic equation in the variable t1. So we get two solutions for the variable t1. So we get the solution t1 equals tau plus square root of tau square minus 4 v average tau divided by 3.6 w divided by 2, and second value is tau minus square root of tau square minus 4 v average tau divided by 3.6 w divided by 2. The value of t2 is tau minus 2 t1 from the equation 3. So we get the value of t2 by putting the value of t1 from the value obtained here. So we get two values of t2 also, which is plus minus square root of tau square minus 4 v average tau divided by 3.6 w. The value of time cannot be negative, so the only acceptable value is the plus square root of tau square minus 4 v average tau divided by 3.6 w. So we can evaluate the value of t2 by putting the value of tau, v average and w in this equation. We get tau equals 25 seconds, v average equals 72 km per hour and w equals 5 meter per second square. So if you put these values at this equation, we get the value of t2 as 15 seconds.